What would happen if Earth were the size of Jupiter? Hello, welcome to the channel. So far, up to 2,000 planets have been discovered outside our solar system. We have just reached Pluto. But have you ever wondered how we know what planets look like? Telescopes, right? Well, in a way, yes, but maybe not exactly as you think. The fact is that we cannot see any planet outside the solar system with telescopes from here on Earth. The largest telescope at the moment is located in the Canary Islands, and its lens is 10.4 meters in diameter. Its range is very limited. If you were to focus the telescope on the moon and wanted to see the objects left by astronauts, you wouldn't be able to see anything. For that, you would need a much larger telescope, one with a 200-meter diameter lens. Not even the Hubble telescope can see the objects left on the moon. According to the Discovery magazine, if you were to build a stadium on the moon and focus the Hubble telescope on it, you would only see a point. This is very surprising for some, especially considering the popularity of the Hubble's photos that we all know, such as those of galaxies or nebulae. However, you have to keep in mind that these nebulae and galaxies are billions of times larger than the moon. Nonetheless, there is a trick we can use to see objects on the moon. We can see their shadows. From a certain perspective, the shadows of objects can be much larger than the objects themselves. As we all know, astronomers use shadows to detect planets far beyond our solar system, but in a different way. To detect planets outside our solar system, NASA uses Kepler, not the astronomer Kepler, but the object in space. Technically, Kepler is a spacecraft that doesn't need crew members to be called that way. At the same time, it is a satellite since it orbits a body, not the Earth, but rather the Sun. It is also a space observatory. Thanks to Kepler, we have news about newly discovered planets. Basically, this observatory, satellite, and spacecraft focuses on a portion of the sky and begins its search. Since its launch in 2009, it has confirmed the discovery of nearly 2,000 planets outside our solar system, only in that small portion. But how does it do it? Kepler is not powerful enough to specifically see a planet outside our solar system. What it does is search for stars because the light from stars is very powerful and obscures objects around them, such as planets, making them difficult to see. What Kepler does is look for the regularity produced when a body passes in front of the star and between the lens of its telescope. Based on this, other data can be obtained, such as the distance of the planet, the duration of its orbit, and its size. Out of the nearly 2,000 planets confirmed by Kepler, only 12 are within the habitable zone. For a planet to be considered habitable, it must meet certain requirements, such as having water. Another requirement is not being too close to the sun or its star, so it doesn't turn into a lava inferno, or being too far away, so it doesn't become frozen. Let's delve a bit into rocky planets in our solar system. For example, small planets are rocky, and large planets are gas giants. This seems to be a general rule in the universe. Neither Saturn nor Jupiter have a solid surface. Jupiter, for example, has clouds on top, then gaseous hydrogen, liquid hydrogen, and metallic hydrogen, which is a kind of liquid metal. Finally, it is theorized to have a small solid core. But what would happen if Earth were the size of Jupiter? According to what we just mentioned, Earth would then be a gas giant and couldn't support life because there is a limit to being a rocky planet, which is roughly 10 times the mass of Earth. If a planet exceeds that limit, it becomes a gas giant. But this is a very ambiguous question because size, mass, and radius are very different concepts. But let's suppose it is possible. Let's suppose Earth is gigantic. Jupiter has the mass of 300 Earths, so there would be a problem with density. If you try to recreate a solid object with such mass, its radius would be much smaller than that of Jupiter, and the surface gravity would be crushing. Normally, Jupiter has a gravity that is 2.5 times that of Earth, but Jupiter is gaseous and doesn't have a solid surface to stand on. In this super-Earth, due to having a solid surface to stand on, the crushing gravity would be 7 times that of Earth. So, if you were expecting to see giant superhuman beings like in the movie Attack on Titan, no, humans would be much smaller than what we see now. One last thing, it took Earth, the Earth we see now, billions of years to cool down from being a solid rock with eruptions everywhere. The fact that it would be much larger in mass would also mean that it would take much longer to cool down, which indicates that there would be no living beings at the moment, only volcanoes, and it would be hellish. Our imagination is the only thing that can make us ask these kinds of questions. And that's it for the video. If you liked it, please like and subscribe.